So the first thing we're going to talk about is statements and truth values. What is truth? All right. Very often in the world, you will hear the term relative truth, meaning that truth has different meanings for different people. That is not true. All right. Something is either true or false. Always either true or false. It's not true for one person and true for another or something like that. So when we talk about defining truth, obviously as Christians, our first definition of truth and only definition of truth is based in the Bible. And then as we talked about, there's design in God's creation. So are there things in creation that we know to be true? And so in math, you see a lot of truth, right? You see a lot of 2 + 2 is always 4. It's not like you can come up with another answer to that and be correct. There's only one right answer to 2 + 2. Okay, and so you have definite truth. And so when we start looking at these statements that we're going to do, we're going to determine whether or not they are true. And so the first definition that you come to is the definition for statement. A statement is a sentence that is either true or false. So a statement is a sentence that is either true or false. And so we call that value that we have placed on it, the true or false, we call that the truth value. So we call that the truth value. And so when we do statements, we are going to represent them with variables. And the reason we do this is so that we can very quickly decide what we're going to do with the statement itself. And so usually for these, they use the variables P and Q here. P and Q. And sometimes they'll use R or something like that if they have multiple statements after that as well. And so the example here, the statement they gave us, supplementary angles have a sum of 180. This is actually true. We haven't actually learned this yet, but this is a true statement. And so we would assign that truth value true because the statement that they gave us was true. All right? The statement was true. So for every statement we're going to look at, we're going to determine the truth value. And then we are going to do some combinations, some negations, and we're going to determine the truth value of the entire thing. All right? The next thing that we talk about is the term negation. The term negation. All right? And this is at the top of page 61 in your books. The negation of a statement has the opposite truth value, which makes sense. If something is true, then the opposite of it is not true or false. All right? The symbol for this, so the symbol for negation is just a little line like that. All right? That is the symbol for negation. So when you see that in front of a statement, that means not whatever the statement is. So if the statement was P, you would see the little symbol in front of P and you would say not P. All right? And so for the example that they just gave us, supplementary angles do not have a sum of 180. Well, if we said supplementary angles do have a sum of 180, the negation would be do not, and the negation would be false because the initial statement was true. The initial statement was true. So let's look at example 1 in your books on page 61. Negate each statement. There exists a student who gets straight A's. The negation of that would be what? No students get straight A's, or there does not exist a student who gets straight A's. In some ways, you would negate it. Q, some pies are not cherry pies. If I wanted to negate that, I would say all pies are cherry pies. We're not determining the truth value of these at this point, right? Because we know the truth value is some students do get straight A's. The truth value is that some pies are not cherry pies. But the negation of that would be to just say something that means the exact opposite. All pies are cherry pies. That would negate it. Why wouldn't I just say some are cherry pies? Because those would both be true, right? Some are, some are not. We have to actually negate it. So saying all of them are would actually be the opposite of the statement. No square is a circle. That is true. But the negation of that would be that there, you could, and you don't have to say all. You could actually say there is a square that is a circle because it said none. So you don't have to necessarily negate an exclusive with an exclusive. You can just negate it with a sum because that's one example would be an exclusion of it. Make sense? You could say all, but you could actually just say some as well. All right, so negation, that just does the opposite of whatever it's told you. Whatever it's told you, it's given you the opposite. All right, let's look at compound statements. So compound statements just put two statements together. It's just like in English, okay? All right, just like in English, you put two statements together, you get a compound statement. So the first type of compound statement is a conjunction. All right, the definition of conjunction. A conjunction is a compound statement formed by connecting two statements with the word and. All right, so you are connecting two statements joined by the word and. By the word and. All right. Now, the conjunction is read P and Q, and your notation is this, what looks like an upside down V. So your notation for it is the upside down V. So your joining word is and your notation is that upside down looking V. All right? These are true only when both of your statements are true. Okay? So your compound statement would be true only when both are true. When both are true. Okay? So if I said I am going to the store and to Chick-fil-A, in order for that statement to be true, both would have to happen. If I just went to the store and I didn't go to Chick-fil-A, what I told you actually wasn't true because I said I was doing both of those. All right? Think about when your parents, hey, when I'm gone, I want you to load the dishwasher and do your laundry. I promise when they get home, if you only did one, you didn't obey, right? If they said or, then that leaves it up in the air. We can do either one or both, whatever. But the and makes it definite. They both have to be true for the entire statement to be true. So if it is joined by and, both pieces of it have to be true. All right? The other type is a disjunction. A disjunction is a compound sentence formed by the word or. By the word or. So your connecting word here is or. All right? And your notation looks like this upside down V. It is written with a P, and then this regular V, right? Looks a little bit larger than a V, Q, okay? So your and is the upside down, your or is the right side up. All right, this is or. Or is joined for a disjunction, and that is your notation. Now for this one to be true, at least one of them has to be true. So with this one, at least one of these. At least one statement is true. In fact, the only way this is false is if both statements are false. So with an or, as long as one piece of it is true, the whole entire statement is true. The whole statement is true. All right? So conjunction is and, disjunction is or. Conjunction is and, disjunction is or. All right? So let's do some examples on your handout. All right? Your handout, we have the three statements here. The first statement is there are 7 days in a week. The second statement is March has 30 days. The third statement is Halloween is on October 31st. So when you're doing these, the first thing you want to do is figure out which of these statements are true and false. So let's go through these first and say, okay, what's true, what's false? There are 7 days in a week. Is that true or false? That is true. March has 30 days. Is that true or false? It's false. March has 31 days. Halloween is on October 31st. That is true, okay? And so what they want us to do is they want us to put these together using whatever notation they told us, and then they want us to find the truth value. So if they have this statement here, the way it is, we're going to determine, do we have a conjunction or a disjunction? We write it out, and then we determine if it is true. Okay? So this is P, Q, and then what's in between it? Conjunction or disjunction? This is a conjunction. So we are going to write the P statement. There are 7 days in a week. And then we are going to write our conjunction, which is what? And or? This is an and. So we have comma and And then going to write our second one, which is Q. March has 30 days. Now, this is an and, which means both pieces have to be true. Are both pieces true? No. So that means this entire sentence is false. This entire sentence is false. All right? So go ahead and do 2 by yourself. The 2 statements that you should have used were what? Right, March has 30 days, and then comma, and Halloween is on October 31st. Was that true or false? False. Why? Which piece of that makes that false? March has 30 days, okay? Also do this with negations, all right? So look at the next page, number 4. Negate P and Q. Negate P and Q. So what is P here? P is there are 7 days in a week. Q is March has 30 days. Which one do they want us to negate? Yeah, the 7 days. So you really just have to add the word not here, and that's sufficient. You could say, there are not 7 days in a week. And then what would we write? And what? March has 30 days. So we do not necessarily negate the second one because they did not put a negation in front of that one. So then we would just say, and March has 30 days. Is this true? No, because neither one of them are true. The truth value of and means they both have to be true. So I'm going to say false here as well. False here as well. All right? All right, so go ahead and do this one on your own. 6. And determine your truth. All right, so this one was what? And or? This is or. All right, they wanted you to negate Q. So by negating Q, you should have said March does not have 30 days. March does not have 30 days. Or Halloween is on October 31st. Which ones were true? Both. So this entire statement is true. Okay, with or, you could have had one piece of it true or both pieces of it true. As long as at least one is true, the entire statement is true. So you would have said true here. This was a true statement. True statement, or just needs one of them to be true. Just one of them to be true. All right? So let's look at how we depict these. Look in your book on page 61. So we're going to look at what's called truth tables, all right? And what truth tables do is they give you all possible combinations of statements. So you're not actually given specific statements typically when you do a truth table. You are just given comparisons between statements. And you are going to go through and say it could be true, it could be false. Here's all the combinations that it could be. So then what are my answers as far as those combinations go? All right? So if I have a P statement, whatever it may be, it could either be true or false. Those are the only options for that statement, correct? Yes? So then if I look at the negation of the P statement, if it was true, then the negation of that statement is going to be false, all right? If the statement was false, then the negation of that statement would be true, okay? So these are my only options for a statement. It's either true or false. The negation of it is going to be either true or false, all right? So both statements can be true for a conjunction. So let's look at this conjunction. Christmas is in December and February has 31 days. That is false, right? We know that's false because the second statement is false. But let's look at the truth table and look at all the combinations, all right? So for my P statement, the options are that it can be true or it can be false, right? Those are the only options for that statement. If we combine it with the second statement, the first one could be true and the second one could also be true. That's one combination, right? Or the first one could be true and the second one could be false, right? What happens if the first one's false? Well, it could be false and the second one could be true, or they could both be false. So when you have two statements, these are your groupings that you're going to have. You're going to have true, 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 false, false, true, false, false. Those are your combinations of those two statements, all right? So let's see what happens if we're looking at and. Remember with and, both pieces have to be true, okay? So let's look at this first one. The first statement is true. The second statement is true. So is the and statement true? Yes. So for this piece of the truth table, I would say true. All right, let's look at the next one. My first statement is true. My second statement is false. Is the and true? No. What about the third one? Is that one true? No. What about the fourth one? No. All right, so this is what a truth table would look like, comparing two statements and the conjunction of those two statements. All right, that's what the truth table would look like. And so if you flip to the second page of your handout, you have truth tables. All right, we have truth tables, and we're going to do a couple of these. All right, first let's look at just the one we just did. That one's right there, the and then we're going to look at the or. So a negation one's easy. If I have one statement, it can be true or false. Then the negation is going to be false or true. We just did this one for and. We have to have both of them true. So it looks like this. Let's look at or. My combinations are the same. I can have two trues, a true false, a false true, a false false. But for or, what happens? For the first one, they're both true. So what about my or statement? Is it true or false? True. Second one, the first statement is true, the second one's false. The or is true. Third one, true or false? What about the last one? False. At least one of them has to be true. Okay, at least one of them has to be true. So this is how you do truth tables. You set them up with all your possible combinations, and then you decide if your statement on the other side is true or false. And sometimes you have to do it piece by piece. So we're going to do some that are a little bit bigger. All right, let's look at the first one together, number one. Number one on your handout. All right, P or not Q. All right, so what we're going to do for this is we are going to set up all of my combinations. So I'm going to do a column for P. I'm going to do a column for R. Then I'm going to do a column for not R. And then I am going to do the one that I'm actually trying to answer. Okay? So this is how this truth table is going to work. We're going to do a P column and R column. We're going to look at what happens with not R. Then we're going to compare our P column to our not R column. All right? So our possibilities here, we could have both true, right? We could have the first one true and the second one false. We could have the first one false and the second one true. And then we could have them both false. Okay? Both false. Everybody see that's my possible combinations of those two. Yes? So let's look at my negation column. For this first one, my R was true, so what is my negation of R? False. My R was false. What's my negation of R? Next one. False and then true. Okay? Now for my last one, which two columns am I comparing? I'm comparing my first column, right, to my third column here, right? Those are the two I'm comparing. Am I comparing by and or by or? By or. So I just need one of them to be true. Just one. So then let's look at the first one. P or not R. For this one, do I have one of them true? Yes, my P is true. So this one here is true. All right. For the second one, do I have at least one of them true? Yes. Third one, do I have at least one of them true? Yes. No, I don't, right? I have false and false there. So this one is false. I'm comparing the first and the third. That's why you have to do it this way so you know which ones you're comparing. What about the last one? Do I have at least one of them true? Yes. All right, so try number 2 on your own. what you want to do is you want to break it up, right? And you have to think about all your possibilities here, all of your possibilities. So you are going to have a column for P, a column for Q, a column for R. Then you want to do your parentheses. Your parentheses want to have their own column. So we want a parentheses for Q and R. And then we want to compare our P column with an OR to our Q and R column. All right? So we want to compare those. So anytime you have parentheses, you want to kind of set it apart. And sometimes they'll give you parentheses with a negation. So you want to do your 3 variables or whatever, your negation, your parentheses, and then your big guy to compare them all to. All right? So when we have something like this, we have, basically what happens is you have the first one, they can all be true, right? That's one of your possibilities, right? Or you could have just the first 2 that are true. Okay? Something like that. Well, then you could still have the first one true, but then this guy could be false. And that same thing could happen with the third one. All right? So basically you have 4 possibilities of the first one being true. They could all be true. One of the other ones could be true. Either the second one or the third one could be true. Or the other 2 could be false. Those are your possibilities for that. And then you have the same exact combinations with the first one being false. Okay? So then you're just going to repeat that, but with the first one being false. So all of these will be false. And then you will just repeat this pattern. Well, we could have a true, and a false, and a false. A true, a false, a true, a false. All right? So you could have all 3 of them true, the first one true with one or the other false, or the first one true with both of them false. And then those same combinations could happen with the first one being false. So you would just repeat that. All right? So I promise setting up this piece is really the hardest part of these big ones, is figuring out all your combinations. All right? Figuring out your combinations. So now we just do it a piece at a time. For the third column, we are going to compare Q and R. All right? So we are going to compare Q column to R column with an and. What does that mean? They both have to be true. So anytime either one of those columns is false, we're going to write false. So this one's going to be true, but here we go. Those are all false. This one's going to be true because we're only comparing those 2 columns, right? And then all of these are false. Okay? Does everybody see that? Everybody see that we're just comparing those 2, and it's an and. So that means both of them have to be true in order for it to be true. All right? Once we've done that column, we can actually just do the last one by comparing 2 columns, right? We can compare the first column, because it's P, compared to this column. We've already calculated what our parentheses is, right? And we are comparing those 2 with an or an and. What are we comparing those 2 with? These 2 columns here, what are we comparing them with? An or, right? So P, this column, or Q and R, this column, right? Comparing this to this, which means only one of them has to be true for this column to be true. All right? So, between the first and the last column here, do I have at least one true? Yes. What about the next one? Do I have at least one true? Yes. What about the next one? Yes, because the first one's true. What about this guy? Do I have at least one true? Yes. What about this one? No. What about this one? No. And what about this one? No. That is my truth table for this one.